symptoms of an irrigation zone that will not activate usually don't show up until it's already too late. Wilted or water-stressed plants are often signs of an irrigation system that's not working correctly. In this video, we will review the troubleshooting steps to identify the cause of a zone that won't activate. Through this process, we will pinpoint the causes of the problem so you know what needs to be repaired to get the zone working again. We'll follow a process that uses the volt-ohm meter to diagnose problems. Using a meter properly and systematically will save you from trial and error, and can often eliminate the need to dig up the landscape in search of the problem. Before we dive into troubleshooting, let's check some basic things that might cause an irrigation zone not to activate. Sometimes problems have simple causes, so let's rule these out first. Verify that there is water pressure to the system. Sometimes the main supply valve or one of the valves on the backflow preventer may have been turned off inadvertently. You can check for water pressure either by operating the zone valve manually or opening a water outlet on the main line. Next, check that there is power to the irrigation controller. Do not assume that a display on the controller indicates that there is power, as the display can be powered by the battery backup. If the controller is activating other zones okay, we know it has power. But if the entire system won't activate, make sure to verify power at the controller's outlet with a test light or voltage meter. Third, many reported failures with zones not activating can actually be related to programming errors. Be sure to activate a manual test of the zone from the controller. If the zone works manually from the controller but does not work automatically, it is likely that you have a controller programming issue. Once you've verified these basics, it's time to begin electrical testing. Using the voltage meter, let's verify the output from the irrigation controller to the zone in question. In this case, our problem zone is number 4. Locate the output on the terminal block for that zone, labeled number 4. We will perform this test with the voltage meter in the volts, AC, or VAC dial position. Activate zone 4 manually on the controller. Now touch the red probe to the zone 4 terminal and the black probe to the common terminal. Be sure to make good contact. The meter should read approximately 24 volts AC. Normal readings will be between 22 and 30 volts. Output that is below 20 volts is unlikely to activate a zone valve and indicates a problem with your controller. If you have adequate voltage coming from the controller as we see here, proceed to the next step to continue troubleshooting. In this next test, we will use the volt-ohm meter to check the electrical continuity of the circuit of wiring from the controller to the valve. This will test all the wiring, splices, and the valve solenoid. The readings that we receive will give us indicators of where we need to look next. In this test, it is important to have the power off to the zone valves at the controller. Forgetting to turn off the power can cause damage to your test equipment. Disconnect the 2 wires that make up the valve circuit from the terminal strip. In this case, it is the zone wire, number 4, and the common wire. Be sure to note which wire is which so you can reconnect them correctly when the test is complete. Set the meter to the ohm setting, which measures electrical resistance. This is often indicated by the omega symbol. In this setting, the meter will send current through the circuit to measure its health. Now touch the red probe to the zone wire and the black probe to the common wire. A normal reading for a valve circuit will be 20 to 60 ohms, depending on the length of the wire and the type of solenoid valve. If you're getting a normal ohm reading but the valve is not activating, it is very likely that the issue is related to a mechanical problem within the valve itself rather than an electrical problem. A low ohm reading, below 20 ohms, indicates the presence of a short. A short indicates that the current is taking a shorter path to the ground. Most often this is because of a bad solenoid on the valve. It can also be caused by a bad electrical splice at the valve or in the wire from the controller. An infinity reading indicates an open or broken circuit. This is usually caused by a wire that has been cut in the field or a bad wire splice. A high ohm reading will keep the zone from operating and almost always indicates a wire splice that has corroded. Depending on the reading, you have identified an issue with either the wiring, one or more splices, or the irrigation valve itself. For issues associated with wire splices or solving electrical problems at the irrigation valve, we have additional videos to help you work with electrical problems with these components.